Hello everybody. So I got a few questions today about that were very specific about calculating binomial probabilities. Okay, and I've already made a video about how to do that, but I thought that it wouldn't hurt to make another video to emphasize some things I didn't emphasize in the first video. Specifically about how you might use a handheld calculator. I got the feeling that based on the question somebody asked me that they were trying to do binomial calculations on something like this, okay? So just if that's the case, I want to talk about it, all right? So there's three ways that we can do this. You can use a handheld calculator, as I mentioned. You can use StatCrunch, which is included with my math lab, and makes all this very easy to do, okay? And you can also use Excel, and I mentioned Excel because StatCrunch might be included with my math lab, but there's a good chance that someday, as you progress in your education and career, that you will be using Excel for things. So if you don't know how to use Excel, I think now is not a bad time to get started on it. All right. So let's talk about these three ways. Now, before I do that, I always feel good when I make a video to remind you of the setting, okay? So we're going to calculate binomial probabilities. Those will come from the scenario of having a binomial experiment. In a binomial experiment, there will be a certain number of trials, meaning we're going to do something identical over and over again n times. That's the number of trials, okay? Like we can ask somebody a question and they say yes or no, and we repeat that and ask different people the same question and they say yes or no. Okay, so that's the first thing. Two, there's only two possible outcomes on any one trial. You could say yes or no, or it's more typical in a binomial experiment to say that the only two possible outcomes on any trial are success or failure. But you can call it whatever you want, but there's just two possible outcomes on any trial. Yes or no, success or failure, up and down, like whatever you want it to be. Okay. And third thing is P will be the probability of success, whatever you're calling success on any trial. That's P. And Q will be the probability of failure, and Q is 1 take away P. Okay. Now, if you can identify all this, then our formula for calculating the probability of X successes out of N total trials is n factorial over n take away x factorial P, probability of success, to the x power, times Q, probability of failure, to the power n take away x. That exclamation point is called a factorial, okay? And it's something that you can do with a calculator like this if you need to. Now, let's go through each way that we might do this. One with a handheld calculator, 2 with StatCrunch, and 3 with Excel. Okay, so the question I decided to do was one somebody sent me, and here it is. The scenario is from my math lab. The scenario is that it's known, let's say by survey of some kind, that 41% of employees judge their peers by the cleanliness of their workspaces. Suppose that our binomial experiment goes like this. You randomly select 8 employees and go through them one by one and ask them whether they judge their peers by the cleanliness of their workspace. Okay, so that's a binomial experiment because you have 8 people and you're going to go through one by one and say, do you judge your peers by the cleanliness of their workspace? And they say yes or no, let's say. Or they say yes, or they say something besides yes, like leave me alone, I don't care, whatever the case might be, all right? But there's only two outcomes. They either say yes or they don't say yes on any one trial, okay? So the trials are that we will ask a worker if they judge others by how clean their workspace is. Success is they respond yes. The probability of that is 0.41, taken from the question because here it says 41% of employees are known to judge peers by the cleanliness of their workspace. Okay, and we're going to ask 8 workers, so 8 trials total. Now, I want to do this last part because this is what the question that somebody sent to me was about, which is this last one. This is the distribution, and you could say that if x is 0, that means the probability that none of the 8 people you ask say that they judge their peers by how clean the workspace is. 0.41. That means the probability of 1 out of the 8 people you ask judge their peers by how clean their workspace is. So that's what all these mean. And I want to do this last one because this is the one they sent me, which says 8, the probability that 8 out of the 8 people you ask judge their peers by how clean their workspace is. Okay, now we would do that like this. I want to calculate the probability of 8 out of 8 people, 8 out of all the 8 that you surveyed, say yes to the question. That's the probability of 8 successes out of 8 trials total. That means X is 8, N is 8. X is the number of successes out of the total number of trials. N is the total number of trials, which is 8. P, the probability that they say yes, 0.41. Q, the probability that they don't say yes, is 0.59. Remember, Q is 1 take away P. Okay, so here's how I would do this with a handheld calculator. There's our formula. That's how you calculate the probability that there will be X successes out of N total tries. Right there. So I've got this formula here, okay? And I put in the numbers. I put 8 for N, I put 8 for N and 8 for X because they're both 8, and it goes in and it looks like this. P is 0.41, Q is 0.59, and so on. That's what it looks like when I put everything in. And then I have to calculate that. Now, I can't really show you very well what the functions and keys on my calculator look like, so we'll do like this. So here's like a online calculator, and that, see that exclamation point? That's the factorial button, okay? So if I wanted to do 8 factorial, I would have to type in 8 and then, hit that key. So, if you have a handheld calculator and it's a scientific calculator, somewhere either on one of the keys or in the menus, it will have that exclamation point. It might vary by calculator how you find that, but it'll be in there. And you'll have to find it. If you can't find it, you can tell me what kind of calculator you have and I can let you know where it is, okay? So that's 8 factorial. So you see that like 8 factorial is 40,320. Okay. So you see I put like in my next step, 8 factorial is 40,320. Now here's the catch with doing this by calculator. Sometimes students, I've observed, they want to calculate every number individually and then write it down one step at a time. And here's the problem if you do that. You're going to have to round the numbers most likely in order to write them down. And when you round the numbers, you introduce rounding error, and then if you do math with a number that has rounding error in it, you'll probably magnify the error. And then that could, by the time you're done, that could throw your answer way off. So I need to, if you're going to use a handheld calculator, I'm going to need to get you to do this all in one step, meaning that although I can calculate all these numbers one at a time, okay, and write them down one at a time, and do this one step at a time, I'm not recommending you do it that way, and I'm not going to do it that way. If you're going to use a handheld calculator, we want to do it in one step as much as possible, okay? So here's what I'll do. All right, I want to do this. Rather than calculate one number at a time, I'm going to type the whole thing in, and I want to type it in like that. Most likely, if you have a scientific calculator, you will have the ability to do that. You might not be able to see the whole thing on the screen at once, but you can put it in like this. So here I've got my online calculator so you can see what I'm doing. But I'm going to do 8 factorial. If I just press the divide button, it puts it in a fraction form already. Okay, so that's good. And then what do I have from there? I get 8 minus 8 factorial. That's 0 factorial. Okay, so 0 then factorial, and then times 8 factorial. Okay, and then out here I'm going to do 0.41, and I need to raise it to a power. And this, a key something like this is how we would do that. So the power is 8, and then I want to do 0.59, and I want to raise that to a power, and the power is 0. 8 take away 8. So I'll do like that, and then there's my number. Okay. All right, so I did it in a calculator all in one step. I did not calculate each number write it down, round it, and keep going. That's not how I did it, and I don't want you to do it that way. Put it in like this, the way that it looks on paper. And again, if you're not sure how to do that on your calculator and you want to figure it out, you have to tell me what kind of calculator you have, because my advice to you might vary a little bit depending on what kind you have. But my goal is that I want to put it in something like this, the way that it looks on paper. All right. Okay, so here's my number right there. It says 7.98492 times 10 to the minus fourth power. Now that's called scientific notation. And that's not what my math lab is expecting us to put in here. It says we'll type a decimal, okay? All right, so we got something called scientific notation back in our calculator, and that may happen to you if you're using a calculator. So I'll mention real quick, there's that number. That times 10 to the minus fourth power just means that we're going to take this number, 7.98493, and we're going to move the decimal left 4 spaces. So if I do that, it's going to look like this. There you're seeing it. Say I take that decimal and scoot it left 4 places and the zeros show up in the empty spots. I'll get 0.00078493. Okay? So we'll put, since it says in the question to type decimals rounded to 4 decimal places, 0.0008. That's 4 decimal places. If I round to that spot right there where the 7 is, where the next number is a 9, it's going to be 0.0008. Okay? All right. So yeah, you might get scientific notation in your calculator. So it does happen sometimes. So that's how you can do this with a handheld calculator. That's at least what I'll recommend to you. I do think it'd be like far easier to use StatCrunch. Okay? So maybe as an alternative to, I think it's nice if you know how to use your calculator just in case you need to. All right. The StatCrunch is included with my math lab, but you might not have it someday. I don't know what you're going to do after this. So, well, we covered that, but we should talk about StatCrunch because it is relevant and it's included with our class this semester. So we'll do it that way too. So let's see, I'm going to try to open it like this. So I'm going to go here. And if I'm in my math lab myself and I'm doing an assignment or something like that, then I would go to StatCrunch. And one way or another, I'd open it up. Okay. All right. So what we want to do is, in StatCrunch, we want to go to calculators and binomial. Okay. All right. And it pulls up this thing called the binomial calculator. And the way that we would do this in StatCrunch, if I want to calculate, what was it? Let's go up here again. The probability of 8 successes in 8 trials. Okay. So I have 8 trials. So I type in 8 for that. Okay. And I want the probability that there are exactly 8 successes. So I would type in x equals 8. Okay. The probability of success was 0.41, I think, was it? Yes. And so 8 trials, probability of success 0.41. And here I'm calculating the probability that there are 8 successes in 8 trials. Okay, so we'll compute. There's that number I just got, 0.000799849. It's exactly the same thing that I got with my calculator. All right, my handheld calculator, StatCrunch, gives me the same thing. All right, so that's what would go in, whoops. Hold on. That's what would go right here. Okay, now we can calculate any of these others the same way. So like if you wanted to calculate what's the probability of 2 successes in 8 trials total, then we would make this a 2 and go on from there. Okay, 0.1985 is 0.1985 right there, 4 decimal places. Okay, so that's how we can use StatCrunch to do the same thing. And one more thing I mentioned about Excel, and I think everybody should learn to use Excel. So let's talk about that. In Excel, I might do something like this. Now, I've prepared this ahead of time. and I made it kind of colorful to make things stand out. We need to know 3 things to do this in Excel. N, the number of trials total, that was 8. P, the probability of success on any one trial, that was 0.41, 41% chance. And in the question that I mentioned, we were going to find the probability of 8 successes out of 8 trials total. So that would be 8. Okay. Now the function that you use in Excel to calculate the probability of there being exactly this many successes in this many trials is binomial distribution. So there it is, binom.dist. Okay. Now it asks you to put in 4 numbers. So this first number, the number of trials, so I typed in for that. Let's do like this. The number of successes you want is the first number. That's this. Okay. Now I can either type an 8 in there, or if I have that number somewhere else because I labeled it, I can click that cell. Okay. Then we put a comma. So that first number is how many successes do you want to calculate the probability of there being. The next number, how many trials total are there? Okay, so I've typed a comma, and then this is the number of trials total. So that's my next one. I put a comma. The next number is what's the probability of success? Well, again, I typed that right here. It's 0.41. So I click that. And this last number is in case you wanted to calculate a cumulative probability, which we don't in this case. And I'm just showing you how you can calculate an individual probability. So if you put 0, then it will behave the way we want it to be. So if I type 0 in that last spot, it will calculate the probability of there being exactly whatever that first number was, successes out of the total trials. Okay, so do that, and there's that same number again that I got with the handheld calculator and with StatCrunch, and now here in Excel. Okay, all right, now it's, when I use Excel, like I type things in boxes separate from the formulas, and then if I wanted to change one of them, what are the probability of 2 successes out of 8 trials? I could change that to 2 and hit enter, and there's what we got for that second answer, right? So what was that number? 0.1985. All right, so yes, that's what I got right there. So you can use Excel that way if needed, all right, sometime in the future, to do the same thing that StatCrunch or a handheld calculator can do. Now, I'm going to recommend StatCrunch. I think that this can be difficult with a handheld calculator, all right? It's far easier with StatCrunch or Excel, but there I've discussed 3 methods. I just, for the sake of the video in the class, wanted to tell you about them, have you try them, and choose whichever one that you think is best for now.